this is the step 1 of our project, and this is the things that are required. First is the parts. First is Arduino Pro Mini 328P. Second is the breadboard. Third is MPU 6050 gyroscope. Number 4, 24 NeoPixel lead ring. Number 5, 4 AA battery pack with 4 batteries. Number 6, the U-shaped jumper cables. And these are the tools that we need to use. First is the USB to serial FTDI adapter FT232RL to program the Arduino Pro Mini. And the second is the Arduino IDE. And the last, it is the skills. So the first skill is the soldering, and number 2, the basic Arduino programming. So that is the step 1, the things required.
Step 3. The code and calibration. First, you need to download and install 2 libraries. The first one is the Adafruit NeoPixel library for controlling the NeoPixel. The second one is the MPU 6050 library for the gyroscope. There are 2 great libraries that will do the heavy lifting in our project. In the calibration,
For step 2, which is assembly, I've attached the freezing schematic in a FZZ format and a picture of it for easy visualization of the connections. Number 1, you need to solder the 3 male pins on the back of the new pixel ring like shown in the picture. Number 1, solder the positive pin. Number 2, solder the ground. And number 3, solder the data input pin. Then number 2, then for the 4 times battery holder, there should have a way of connecting to the breadboard. An easy solution is to solder 2 male DuPont wires to its terminals. And lastly, prepare the breadboard. So how do you do it? Place it in the new pixel ring, microcontroller, and a gyroscope on the breadboard like in the image. So basically it is yes, and along with that, place all the positive wires to the microcontroller, new pixel ring, and gyro. Place all the data wires, the SDA and the SCL from to the microcontroller to the gyro. And lastly, pin D6 from the microcontroller to the new pixel ring. And double check all connections before powering. Also, optionally, using duct tape, tape the battery back on the pack of the breadboard to hold it in place and make it more portable. So those are all the steps regarding the assembly. That's all.
Step 4. How it works. First, a little information about the MPU 6050 gyroscope. This is a MEMS gyroscope. MEMS stands for Micro Electromechanical Systems. Each type of MEMS gyroscope has some form of oscillating component from where the acceleration and hence direction change can be detected. This is because, as per the conservation of motion law, a vibrating object likes to continue vibrating in the same plane, and any vibrational deviation can be used to derive a change in direction. The gyro also contains a microcontroller of its own to compute the roll, pitch, and yaw through some fancy maths. But the gyro raw data suffers from noise and drift, so we use an external library to smooth things out and give us clean, visible data. The NeoPixel are RGB LEDs, individually addressable and chained into bands and rings. They work on 5 volts and they contain their own circuitry, so you only need to power the NeoPixels and to communicate with them using the data line. The communication is done with a single data line containing clock and data. Adafruit provides a clean library for interacting with the NeoPixel rings. The code. Inside the loop functions, the MPU 6050 6-axis motion apps 20 library is called. When the library has new data from the gyroscope, it calls redraw LEDs XYZ with 3 arguments representing yaw, pitch, and roll. Inside redraw LEDs, we're focusing on 2 axes Y and Z. We're constraining both axes from max angle to plus max angle. We define max angle to 45 in each changeable. We're splitting 360 degrees into 4 quadrants and call light LEDs functions for each as follows. Y negative, Z positive first quadrant will control LEDs 0 to 5 and the angle will from 0 to 89. Y negative, Z negative second quadrant controls LEDs from 6 to 12 angle will be from 89 to 0. Inside the light LEDs function, we're calculating an angle based on the 2 axes using arctangent. We're resetting the lead strip, all 2 leads, the one corresponding to the lead position of calculated. We're also printing the 2 axis, but lead has light angle. The math. We've attached a picture with the lead ring and trigonometric function used to determine the angle.
Stereo support, switchable peak hold function with falling down option, adjustable sensitivity setting, adjustable LED brightness setting, support for 1 LED strip displaying the left and right channel or 2 LED rings displaying 1 channel each, slow falling down of the leads, variables which can be set to support any number of LEDs and further customize the view meter.
So these are the supplies and components for this project. So first on the list is SparkFun Arduino Pro Mini 328 5 volts 16 mHz. Next is Adafruit NeoPixel Ring RGB LED. Next is SparkFun IMU Breakout MPU 9250. Next is the breadboard, so it could be generic. Next is the male jumper wires. Next is the male or male/female jumper wires. Lastly, four AA battery holder plus battery. So that's a total of 7.